Hi everyone, for today's video, we will use the first derivative test in finding the maximum and minimum points. Okay, so these are the problems that we will solve. So we have find the maximum or minimum points for each of the following. So we have three problems. So we will use the first derivative test in finding the maximum and minimum points. So these are the first derivative test, the function y equals f of x is a maximum. Is a maximum for x equals a if y prime, or this is the derivative, y prime is greater than 0 for x is less than a, y prime equals 0 for x equals a, y prime is less than 0 for x is greater than a. So first step in finding the maximum and minimum, we find the critical point. So this is the critical point, x equals a. So first, we will get the derivative, and then equate to 0, solve for x. So that x is the critical point. So we have x equals a. So this is the critical point. Okay, and then we will pick a number less than a and then greater than a. So x is less than a if y prime, the derivative is 0, that means the sign is positive. And then for x is greater than a, we have y prime is less than 0, so that means the sign is negative. So if the sign changes from positive to negative, then that critical number, so that point is a maximum point. And then if it is negative to positive, so this is a minimum point. Okay? So the steps are first, find the critical point. First, find the derivative, equate to 0, solve for x. So that is the critical point. Then, choose a number to the left and to the right of the critical point. If we have positive to negative, we have maximum point, maximum at x equals a, and then if we have negative to positive, that is a minimum. So if there's no change in sign, so positive to positive or negative to negative, then that means the critical point is not a maximum nor minimum. So it's just a critical point. Maybe it's a point of inflection. Okay, so let's solve these three numbers. Okay. Number 1, y equals x squared minus 4x minus 1. So let us find the maximum or minimum point using derivative. Actually, we can find the minimum point of this because this is a quadratic equation. So it's a parabola that opens upward. So, but we will use derivative in finding the minimum point of this quadratic function. Okay? So, first step is find the derivative. So, let's find the derivative. Y prime is equal to derivative of x squared. We have 2x. And then derivative of negative 4x, we have negative 4. Derivative of negative 1 is 0. So, next step, equate the derivative to 0. So 2x minus 4, we have that is equal to 0, and then solve for x. Okay, so find the critical number by finding the derivative, equating to 0, and then solve for x. So we add 4 to both sides. So we have 2x is equal to, this will cancel out, 0 plus 4, we have 4. Then divide both sides by 2. So therefore, x is equal to 2. So this is our critical number. Okay, so now let's set up a table to make the computation easier. So let's summarize in a table. So in the first column, we will write the interval. So in the interval, negative infinity up to positive infinity, so the critical number will divide our interval. So we have two intervals, negative infinity up to the critical number, we have 2. Okay? So let's write the critical number, we have 2, and then the other interval is 2 to positive infinity. Okay? So for the next column, we will write the f of x. Okay, f of x, and then we have f prime of x, and then the last column will be our conclusion if it is increasing or decreasing. Okay, so let's solve first the f of 2. So f of 2, so that means we will substitute 2 in our given equation y equals x squared minus 4x minus 1. Okay, so let us solve f of 2. We have substitute 2 in the given polynomial function. So we have 2 squared minus 4x. So we have minus 4 times 2 and then minus 1. So we have 2 squared is 4. Negative 4 times 2, we have negative 8 and then minus 1. So therefore, 4 minus 8, that is equal to negative 4 minus 1, we have negative 5. Okay, so we have the point is 2, negative 5. Okay, so f prime of x, so that means this is our critical number, so that means f prime of 2, that is equal to 0. Okay, and then let us solve the sign to the left and to the right of the critical number 2. So choose a number from this interval negative infinity up to positive 2. So choose any number. So let's try 0 because 0 is in this interval. And then substitute in the derivative f prime of x. So we have f prime of 0, that is equal to, so this is our derivative. The derivative is 2x minus 4. So substitute f of 0, so we have 2 times 0 minus 4. Okay, so 2 times 0, that is 0. 0 minus 4, so we have negative 4. So remember, we are only interested with the sign. So therefore, in this interval, negative infinity up to 2, when we substitute any number from this interval, the sign of this will always be negative. Okay, so if we substitute, let's try negative number. So if we have negative number here, 2 times negative number, so that is negative number, minus 4, so it's still a negative number. Okay, and then let's choose a number from in this interval 2 to positive infinity. So let's say 10. So we have f prime of 10, substitute 10 in this derivative, so 2x minus 4, so we have 2 times 10 minus 4. So 2 times 10, that will be 20, minus 4, that is equal to 16. Okay, so that is positive. Okay, so therefore, the conclusion in this interval negative infinity up to positive 2, since negative, so f is increasing. The function is or decreasing because negative. So we have decreasing. And then, in this interval 2 to positive infinity, we have positive. So that means f is increasing. So since the sign changes from negative to positive, that means the critical number 2 or the point 2, negative 5 is a from decreasing. So this is the graph of decreasing function. And then decreasing to increasing. Okay, so this is the graph. So it's a parabola. So therefore, 2 negative 5 is a relative, this is a minimum point. Okay, so minimum at 2 negative 5. So therefore, the point 2 negative 5 is a minimum point. So that is a minimum point. So if we draw the graph of that, so we have minimum point of 2 negative 5. So if we want to draw the graph in a Cartesian plane, so we have 2 and then negative 5. Negative 1, negative 2, 3, 4, 5. So this is the graph of our function. Okay. So next, number 2, y equals x to the fifth minus 5x cubed minus 20x minus 2. Okay, so first step is find the derivative. So we have y prime is equal to derivative of x to the fifth. We have 5x to the fourth minus Derivative of 5x cubed is 15. 3 times 5, we have 15. Subtract 1 to the exponent, so we have 15x squared. Derivative of negative 20x is negative 20. Derivative of negative 2 is equal to 0. So next, set the derivative to 0. So we have 5x to the fourth minus 15x squared minus 20 equals 0, and then solve for x. So look at the numerical coefficient. They are all divisible by 5. So let's divide both sides of the equation by 5. So therefore, we have 5 divided by 5, that is 1. So we have x to the fourth. Minus 15 divided by 5, we have 3. Just copy x squared. Negative 20 divided by 5, we have negative 4 equals 0. So next, we can solve this by factoring, since the exponent of the middle is 1/2 the exponent of x to the fourth. Okay? So let's factor negative 4 such that the sum is equal to negative 3. So therefore, we have factors of x to the fourth. We have x squared and then another x squared. Okay? So factors of negative 4 such that the sum is negative 3. We have negative 4 and then positive 1. Okay? So that is equal to 0. Okay, now solve for x. So we have two solutions. So equate each factor to 0. So we have x squared minus 4 equals 0. And then x squared plus 1 equals 0. So solve for x. So we have put negative 4 to the other side by adding 4 to both sides. So we have x squared is equal to 4. Next, extract the square root of both sides. So therefore, x is equal to positive or negative square root of 4. We have 2. Okay, so these are our first set of critical numbers. For this one, we have x squared plus 1 equals 0. So this will be imaginary. Subtract 1 to both sides. We have x squared is equal to negative 1. Then extract the square root of both sides. So we have x is equal to positive or negative square root of negative 1. That is I, imaginary. So therefore, there's no critical number for this part because this is imaginary number. Okay? So therefore, we have two critical numbers, positive and negative 2. So this critical number will divide our interval negative infinity to positive infinity. So therefore, we have 3 subintervals. So the first one is negative infinity up to negative 2. Okay, so let's write the critical numbers. We have negative 2. And then next interval, we have negative 2 up to positive 2. Then let's write the critical number 2. And then last interval is 2 to positive infinity. Okay, so this our table. So the next column is f of x. The third column is the derivative f prime of x. And then the last column is the conclusion. So we will write if it is increasing or decreasing. Okay? So we have at the critical number, we have negative 2 and positive 2. So automatic negative 2, f prime of negative 2, that is 0. Because we solved that by equating the derivative to 0. And then f prime of 2, we have 0 here. So we are only interested with the sign to the left of our critical number, negative 2, and then we have positive 2. So and then let's solve the f of negative 2. So to find the maximum or minimum point. So we have f of negative 2. F of negative 2, so let's substitute that to the original equation. So let's substitute negative 2 for every x. So we have negative 2 to the fifth minus 5. So we have x cubed. So we have negative 2 cubed minus 20 times negative 2 minus 2. Okay, so we have negative 2 to the fifth, we have negative 32. 5 factors of negative 2. Minus 5 times negative 2 cubed, so that is negative 8. And then we have negative 20 times negative 2, we have positive 40, and then minus 2. So let's simplify this. So we can use our calculator to solve that. Okay, so we have negative 32, negative 5 times negative 8. We have positive 40 plus 40 minus 2. So therefore, f of negative 2 is equal to, so we have negative 32 plus 80 minus 2. That is equal to 46. So we have negative 2 and then 46. Okay? So next, we have f of 2. So let's solve f of 2. So we have just replace negative 2 with positive 2. So we have 2 to the fifth power minus 5 times 2 cube minus 20 times 2 and then minus 2. Okay? So we have 2 to the fifth, we have 32 minus 2 to the 2 cube, that is equal to 8 times negative 5, we have negative 40. And then minus 20 times 2, we have negative 40 and then minus 2. So therefore, the answer to that is 32 minus 40 minus 40 minus 2, we have negative 50. Okay? So we have, if f of 2 is equal to negative 50. So now, let's choose a number to the left of this interval, in the interval negative infinity up to negative 2. So this time we will use the derivative. So this derivative y prime. Okay? So let's substitute in this part, or we can use the factored form. So the factored form of this is x squared minus 4 and then we have x squared plus 1. Okay? And then we divide it by 5. So we can put times 5 here. So but we are only interested with the sign. So it's okay if we substitute in the factored form. So choose a number to the in this interval negative infinity up to negative 2. So let's choose negative 5. So we have f prime of negative 5. So let's use this, the factored form. So we have, if negative 5, so we have negative 5 squared minus 4, and then we have negative 5 squared plus 1. Okay? So the sign to this will be negative 5 squared, so this will be positive. Positive 25 minus 4, so the sign will be positive. Okay? For this part, negative 5 squared, so that is 25 plus 1, so the sign is also positive. And then we multiply 2 positive, the answer to that is positive. So to the left of negative 2, we have positive. So therefore, the conclusion is we have increasing. In this interval, negative infinity to negative 2, we have f is increasing. Okay? Next, let's choose negative 2 in the interval negative 2 to positive 2. Let's choose 0. So the easiest number is always 0. So because when we substitute 0 to this, just cancel out the variable. So we have negative 4. So we have negative 4, negative 4. So we have negative, and then substitute 0 to x squared. So this will become 0. So we have positive 1. Okay, so when we multiply that, negative times positive, we have negative. So negative in this part, so positive to negative. So we have decreasing. So the sign changes from positive to negative. So positive to negative, that means this negative 2 to 46. So this is a maximum. This is a maximum point. Okay? So this point is a maximum, negative 2. The point negative 246 is a maximum point because the sign changes from positive to negative. Okay? So let's try, let's choose a number in this interval, 2 to positive infinity. Let's try 10. Okay? So f prime of 10. So substitute in this. So we have 10 squared minus 4 times 10 squared plus 1. So we have 10 squared plus 1. So we're only interested with the sign. 10 squared, that is 100 minus 4. So the sign will be positive. 10 squared is 100 plus 1. So the sign is also positive. So positive times positive equals positive. So the sign will be positive. So therefore, we have in this interval, the sign is, or we have, the sign is positive. So therefore, we have the interval 2 to positive infinity, we have increasing. So therefore, the sign changes from negative to positive. So therefore, we have a minimum point. So this point 2 negative 50 is a minimum point. Okay? So we can draw the graph, we can estimate the graph of this function by plotting these points. And then we know the increasing and decreasing part of the graph of this y equals x to the fifth minus 5x cubed minus 20x minus 2. So let's estimate the graph, and then I will show you the real graph using the GeoGebra. Okay? So let's estimate the graph. We have negative 2 to 46, negative 2, so negative 2 to 46, so 46. So medyo mataas siya. So we have 246. So this is the negative 246. And then we have 2 negative 50. So let's say we have 2 negative 50. This point is 2 negative 50. So we have positive from negative infinity to positive negative infinity up to negative 2, we have increasing. So that means the graph is increasing. So we have just like this. And then from negative 2 to positive 2, so we have this is the negative 2 to positive 2, we have decreasing. So decreasing from this up to this point, we have decreasing. Okay? And then another increasing 2 to positive infinity, another increasing. Therefore, the graph is yan, like that. So let's put arrow to this and then arrow to in this part. Okay? So this is the real graph using the GeoGebra. Okay? Ayan. Okay, so next, let's solve number 3. Y equals 3x to the fourth minus 16x cubed plus 24x squared. So first step, find the derivative. Okay, so we can replace y with f of x. So that's the same. So let's get the derivative. F prime of x is equal to derivative of 3x to the fourth. So just multiply 4 times 3. We have 12. X subtract 1. So we have 12x cubed. Minus 3 times 16. So we have 48. Subtract 1 to the exponent. So we have x squared. Plus 2 times 24. So we have another 48. And then subtract 1 to the exponent, 48x. Okay. So next is equate to 0. Equate to 0. So we have 12x cubed minus 48x squared plus 48x is equal to 0. So we can divide all the numbers. We can divide all the numbers by 12. Okay. So divide all by 12. So we have x cubed. And then we have 48 divided by 12. That is equal to negative 4 x squared. And then 48 divided by 12, another 4. So this time positive. Positive 4x equals 0. Then they all have x. So we can factor out the x. Factor out the x. We have x squared minus 4x plus 4 equals 0. So we can now get the critical numbers. So this part, x squared minus 4x plus 4, so this is a perfect square trinomial. So this can be written as, so we have x, and then this is a perfect square trinomial, so we have x minus 2 squared equals 0. Okay? If we factor that, 4, negative 2 times negative 2, that is equal to positive 4. And then if we add negative 2 and negative 2, the middle will be negative 4x. Okay, so therefore we have x minus 2 squared. So now equate each factor to 0. So we have x, this is the first factor, x equals 0, and the other one is x minus 2 equals 0. So therefore, the critical numbers are x equals 0 and x minus 2. Solve for x, so add 2 to both sides. So therefore, the other critical number is equal to 2. So now, let's draw a table. Draw a table. So for the first part, we have the interval for the first part. And then we have f of x for the second column, f prime of x for the third, and the conclusion for the last part. Okay. So let's write the interval. We have two critical points, so that means we have three intervals. Okay. Okay, so we have negative infinity up to 0. And then let's write the critical number 0. The next interval is 0 to 2. 0 to 2. And then we have, let's write the critical number 2. And then another, we have 2 to positive infinity. Okay. So let's solve when x equals 0, substitute 0 to our function y equals 3x to the fourth minus 16x cubed plus 24x squared. So when we substitute x equals 0, so f of 0 is still 0. So now let's solve, let's substitute 2 to this. So okay, so let's solve. So we have, so substitute f of 2 equals, so we have 3x to the fourth, so we have 3 times 2 to the fourth minus 16, and then we have x cubed, so we have 2 cubed plus 24 times 2 squared. Okay, so we have 3 times, let's just use a calculator for that. So we have 3 times 2 to the fourth, so 2 to the fourth, that is 16. Minus 16 times 2 cubed, so that is 8, plus 24 2 squared, so 24 times 2 squared is 4 times 24, so plus 4 times 24, so therefore we have 16. So f of 2 is equal to 16. So if we have 2, okay, so 2 we have 0.216. Okay? So the critical points are 0, 0, 0.00, the origin, and 0.216. So of course, at the critical number, so f prime of the critical number, we have 0 and 0. So now, let's solve the sign. In this interval, negative infinity up to 0. So let's choose f prime of, let's say, in this interval, so let's say negative 10. Okay? So let's solve negative 10. And then for the interval 0 to 2, so let's choose 1, f prime of 1. And then for this part 2 to positive infinity, let's choose f prime of 10. Okay? So now, let's just substitute. We can just solve the sign. So let's use this is the derivative, the factored form, x times x minus 2 squared. But we divide by 12. If we multiply this by 12, so the sign does not change because 12 is positive. Okay? So let's just substitute negative 10. So we have substitute negative 10 to x. So we have negative 10 times x minus 2. So we have negative 10 minus 2 squared. Okay? So again, we are only interested with the sign. So for 1, so let's replace negative 10 with 1. So we have 1, and then we have 1 minus 2 squared. And then for 10, we have 10 times 10 minus 2 squared. Okay? So let's solve the sign. So negative 10, so we have negative. So this part will always be positive because it's negative 10 minus 2, and then we have squared. So whatever the sign of this, when we square that, the answer is always positive. So we have negative times positive. So this part, we have positive 1. Okay? And then we have square, so the answer will always be positive. For this part, we have positive 10, and then the answer to this, when we squared, we have positive. So let's solve the sign. Negative times positive, we have negative. Positive times positive, we have positive. Positive times positive is also positive. So let's write in the table, put in the table the sign. We have negative, positive, and then positive. Okay, so what is our conclusion here? Negative infinity or negative infinity up to 0, we have negative. So the function is decreasing for this part. And then we have 0 to 2. In the interval 0 to 2, we have positive. So that means the function is increasing for this part. And for the interval 2 to positive infinity, also positive. So therefore, another increasing for this part. So that means we have changes of sign in this interval, negative, naging from negative to positive. So this means this is a negative to positive. So this 0, 0 is a minimum point. Okay? So minimum point. But for this part, we have positive, but also positive. So therefore, the number 216, this is not a maximum and also not a minimum. So maybe this is a point of inflection. So therefore, we only have one minimum point for this function. So the point 0, 0, so the point 0, 0 is a minimum point. Okay, so that is our final answer. 0, 0 is a minimum point. The other point, 216, is not a maximum point. So it's a point of inflection. Okay, so this is the graph. Okay, the graph using the GeoGebra. Okay, so that's all. Thank you for watching. Bye-bye.